Hello, this is Mr. Zanaletta. I'm going to go over lesson 1.4, nonlinear polynomial inequalities. Encourage you to take a few notes as we go through this. Go ahead and solve nonlinear polynomial inequalities. The steps to doing this. The first thing I would do is write the inequality in standard form. That's putting all the variables and constant terms on the left and setting it less than or greater than to 0. You'll see this in a minute. Determine the number that would make the expression on the left side equal to 0. Again, we solved it for 0. Then we go ahead and we factor that. And generally you factor it. If you can't factor it, maybe you go ahead and use the quadratic formula. One of the two you're going to do, and you're going to go ahead and come up with the critical points. Use the number found in step 2 to separate the real numbers into intervals. Again, you'll see this in action. We're going to have intervals to the left of those values, between those values, and to the right of those values. Select a test number in each interval and evaluate the polynomial at each test number to know whether we're going to shade between those or not. If the value is positive, then all the numbers in the interval are positive. If the value is negative, then all the numbers in the interval are negative. You'll see what I mean by that. I really, that part, didn't wrap my mind around that. I did wrap my mind around this. This is really important. Including solutions of polynomials included in inequality. If they're included, that means they're less than equal to, greater than equal to. And note, they're not included. Oops. When it's greater than or less than. So if it's greater than or less than, it's not equal to 0. Therefore, at those critical points, they won't be included. But in this case, our first example is going to have a greater than, I think a less than or equal to. Let's see here. As a less than or equal to. So we're going to end up including that point. And you'll see what I mean by that. And as we go over a couple examples, I think it'll be clear to you. So I'm going to subtract 4x and 12 from both sides. I get x squared minus 4x minus 12 less than or equal to 0. We can easily factor that because factors of 12 that subtract to get me 4. I have x and 6, x and 2. Let's see. 2. And that's going to be less than or equal to 0. Now the signs, I want a negative 6 and a positive 2 to make negative 6x, positive 2x gives me negative 4x. I have my x squared, I have my negative 12. I feel comfortable with that. Now, where is this true? Where is it equal to? Where are those critical points? Those critical points are when these are 0. So when x minus 6 equals 0, that will make that left side 0 and it'll make it true and it'll make the critical point, just like when x plus 2 equals 0. So really we're talking about x equals 6 and x equals negative 2. And those are both true. Why are they true? Because it's equal to it. So I'm going to come down here, I'm going to make a solid point at negative 2. Let me use red so it stands out a little more. And that was true. And I also 6, a solid point, and that's true. Now some other points that I might want to consider. To the left of negative 2, I always like just to use the next integer. It works nice and I can limit how big my numbers are. So negative 3 I would like to put in. 0 is always a convenient number to plug in, and 7's inconvenient. So those are the test values that I'm going to use. X equals negative 3. When x equals negative 3, if I plug that into the original equation, I get positive 9 is less than or equal to negative 12 plus 12. That's 9 is less than or equal to 0. 9 is not less than or equal to 0. That's false. This is false. So therefore, to the left of negative 2, that interval will not be shaded. Then I plug in 0. When x equals 0, I get 0 is less than or equal to 0 plus 12. 0 is less than or equal to 12. That's true. Since that's true, now I know that this interval between negative 2 and 6 between negative 2 and 6 will be true. And then when I plug in the value of 7, when x equals 7, I get 49 is less than or equal to 28 plus 12. That says 49 is less than 40, less than or equal to 40. That's false. So it's not going to be, that's not going to be true to the right of 6. And if I wanted to state, which I would like to do, if I want to state my answer, x is going to equal the values between negative 2 and 6, including negative 2 and 6. And that's writing it in interval notation. So that would be my solution. That's our first example. Let's move on to example number 2. We have, again, an x squared is greater than 5x plus 6. In this case, I'm going to go ahead and move the 5x plus 6. I'm going to subtract them from both sides. And that makes 5x squared minus 5x minus 6 greater than 0. If I think of factors of 6, that subtract to give me 5. I like 6 and 1. And then I want my 6 to be negative and my 1 to be positive to give me my negative 5x. Negative 6 plus 1 multiplied gives me negative 6. X times x squared. X times x gives me x squared. So there I'm set. Now I'm going to go ahead and find those critical points by setting x minus 6 equal to 0 and x plus 1 equal to 0. When I do that, x equals 6 is a critical point and x equals negative 1 is a critical point. So now remember, those are critical points, but they're not included. These are false. In fact, I like jotting down that I knew those were false. Therefore, now I'm going to make a hollow point at negative 1 and a hollow point at 6. Those were false and false. Now, plugging in values. I'm probably going to plug in negative 2, 0, and 7. So when x equals negative 2, I get 4 is greater than negative 10 plus 6. That means 4 is greater than negative 4. That's true. So this is true. If that's true, now I know the interval to the left of negative 1, going off to negative infinity, is going to be true. Those will give us values that would make this true. If I plug in 0, x equals 0, I get 0 is greater than 5 times 0 is 0 plus 6. 0 is greater than 6. That's false. So this is false. Let me scroll that up just a little bit so that you can see me putting those down. Okay, so this is false. So it's not going to be between negative 1 and 6. And if I plug in x equals 7, I get 49 is greater than 35 plus 6, which is 49 is greater than 41, which is true. So this is a true statement, and therefore I want to shade towards it, going off from positive 6 to positive infinity. And if I were to state my answer for that in interval notation, x equals parentheses, because I'm not including the point, well, I don't include negative infinity ever, but it's negative infinity going to negative 1, and that's a parenthesis. The union of that, negative infinity to negative 1, and from 6 to positive infinity. And there we are. That would be the solution set. And that's how we basically solve simple nonlinear inequalities. Thank you.